I'm Anil Kumar. Welcome to my series on kinematics. Let me thank my subscriber Iru for posting most of the questions in this particular playlist. And I hope you all are enjoying the solutions and benefiting. The question here is, a motorcyclist traveling along a straight road passes a fixed point O with a speed of 10 meters per second and continues at this speed for t1 seconds. Over the next 10 seconds, he accelerates at a constant rate to a speed of 15 meters per second. He then brings the motorcycle at rest in a further t2 seconds by retarding at a constant rate. His acceleration and retardation are of equal magnitudes. So this is kind of complicated. I'd like you to pause the video, read it, understand, and then answer the following three parts. A. Sketch a velocity time graph to illustrate the motion of this motorcyclist after passing O. B. Calculate T2. And C is, given the total distance represented by the graph is 850 meters, calculate T1. Well, that's very interesting. So this time we are going to sketch velocity time graph first and then find the displacement and also think about acceleration. So that makes it very exciting. So I'd like you to really pause the video, think about it, and then look into my suggestions. So let's try to sketch velocity time graph first and then we'll answer rest of the questions. Okay. A motorcyclist traveling along a straight road passes a fixed point O. So we'll call this point as O with a speed of 10 meters per second and continues at this speed for t1. So let's say this is 10 for us, right? So and continues for t1. So that is t1 for us. Do you see that part? So what we have done is we have related this in the graph, continues for t1 seconds. Now, over the next 10 seconds, he accelerates at a constant rate to a speed of 15 meters per second. So now, in 10 seconds, the motorcyclist accelerates. So this part is 10 seconds, correct? And this here is now 15. So this was 15. We are talking about velocity in meters per second, right? And initially, the motorcycle was going at 10 meters per second. Do you see that part? Do you understand? So it took 10 seconds to accelerate from 10 to 15. That's what we are trying to say. Okay. He then brings the motorcycle to rest in a further t2 seconds by retarding at a constant rate. His acceleration and retardation are of equal magnitude. So that means the slope is same. Do you see that? So when we say acceleration and retardation are of equal magnitude, that means this slope, right, and the slope of coming down is same. So this is kind of same. Do you see that part? And the time taken is t2. So time taken is t2. That is from here to there. So that becomes the scenario. And clearly we have velocity on the y-axis, time in seconds along the horizontal, and that becomes our VT graph. Is that clear to you? So we have done the first part. So this time here, if you think about it, is t1 plus 10 plus t2. Do you see that? So this part here is t1 plus 10 plus t2. Okay. Now we need to calculate t2. That is, so we have done the first part, which is the sketch. Now let's try to calculate t2. How do we calculate t2? Well, since we know acceleration is same as deceleration, so let's try to figure out what this acceleration is, right? So I'll do it here. Acceleration will be equal to, let's say A will be change in velocity, rate of change in velocity. So it will be 15 minus 10 divided by, and it took 10 seconds. Do you see that part? So that is 5 over 10, or half meters per second square. Perfect. So that is how you get the acceleration. So in this part, the acceleration is half meters per second square. Now deceleration is the same rate, so here deceleration is minus half meters per second square. Do you get the idea? Perfect. Right? Now you can see that the object moved from 10 to 15. That means the velocity changed from 10 to 15 in 10 seconds. So what do we expect? We expect that it will change from 15 to 0, this is 0, right, in 30 seconds. So this is one way. Reasoning to give T2. Do you see that? So from reasoning also you can get the answer. The other way, of course, is that we know the final velocity here is 0, initial is 15, right? And we need to find the time taken. We know the acceleration. So let's do that part. Calculate it algebraically. So in this case, the final velocity is 0. So V final minus V initial divided by T2 is the acceleration. And we know acceleration is minus half, right? So V final is 0. 0 minus 15 over T2 is minus half. So let's cross multiply, right? So when you cross multiply, you get T2 equal to, and you can actually multiply this by minus 2. So minus 15 times minus 2, and that is 30 seconds. Do you see that? So you can algebraically also get the same result. Do you understand? So we get T2 as 30 seconds. So we get 30 seconds for time 2. Now let's try to figure out part C. So I hope up to now everything is absolutely clear, right? Given the total distance represented by the graph as 850 meters, calculate T1. So we need to find this time, T1. And we know total distance is 850. So how do we solve this? Well, how do you find distance from velocity time graph? So the key here is area under the curve. Area under VT graph equals to total distance traveled. So that is the key to find this particular solution. So you can get your equation. Area of the curve is, this is a rectangle, these two are triangles. Do you see that part? So you could find T2, the only T1, the only unknown from the area under this curve, right? So under this curve, so we have one square. So let me write down the equation here. So what we get here, the distance is 850, right? So we get 850 equals to area under the curve. So what is the area of this side? The area here is length into width, which is 10 T1. So it is 10 times T1. Perfect. Plus, what is the area under this curve? So you could actually either do, you could do like this, right? We know this is 10 and 10, 100 and triangle, right? So we'll say 100 plus triangle. So it is 100 plus area of this triangle. Half of 10 times the height. So it is half of 10 times the height, which is 5. Perfect. So this box here is the square 10 by 10 and the triangle. And now finally the area of the bigger triangle, that is area of this triangle. So I have very little space, but I'm giving you the method. You can do the calculations, right? So this is half of T2 is 30 seconds, half of 30 times total height, which is 15. So in this equation, T1 is the only unknown. Perfect. T1 is the only unknown, and so it could be easily calculated. Perfect. So let me push this page a bit in front and do the calculation. So what we get here is, so we have 850 equals to, let me write down here, 850 equals to 10t1, and this half of 5 times 5 is 25 plus 25. 100 I missed, so let me write 100 now. And we have 25, half of 10 times 5, and now half of 30 is 15. 15 times 15 is 225. So that's it. So all this is equal to 850. So that gives you the value of T1, which will be 850 minus all this. So 225 plus 25 is 250 and 100, 350, correct? Divided by 10 will be T1, correct? So let's do this. So that is 50 take away 50 is 0, 0. 8 take away 3 is 5. So 500 divided by 10. So that gives you 50 seconds. So for 50 seconds, it traveled at a constant speed of 10 meters per second. So we get T1 as 50 seconds, correct? So that is how you could actually calculate it. So I didn't move on to a fresh page, but I think at this stage, you are in grade 12, most probably. So you can easily do this particular calculation. So the idea which I want to share with you here is that to find distance from velocity time graph, you need to find area under the curve. So you can always divide this into rectangles and triangles, find the area, and get your answer. I hope that helps. Feel free to write your comments and share your views. And if you really like and subscribe to my videos, that will be great. Thanks for watching and all the best.